Welcome to Unit 2.4. This is the last unit, and it only states that how we can make computers more faster than we have right now, and what is the upcoming future that scientists are working on. So, we already know that different types of CPUs in different times have already tried to become faster and faster. How we can achieve more faster CPUs. One of the example is by using more number of cores in a CPU or more number of transistors in the CPU. Okay, and is thing is making bus speed much faster, because we already know that we have already discussed that CPU is always faster than any other device on your computer. So if the bus speed, if the memory speed is much higher, then the CPU can perform much faster. Okay, smaller components, if the components of different CPUs are much smaller, then data transfer will be much faster, because it has to travel a less amount of space. Okay, so it will be much faster. A CPU is made of different types of material, for example, silicon, for example, gold, for example, carbon. So if we use those material which are lossless, which does not dissipate much heat, which are flexible, which does not degrade over time, that then we can hope for more reliable CPUs in the future, and more longer lasting and more faster CPUs in the future. Pipelining is the process that we already utilize, and we have already discussed pipelining in the previous section. We will discuss pipelining once more with the help of a slide. Okay, so pipelining or parallel processing or multiprocessing is the same thing. What it will do, that it will split the instruction into 3 or 4 parts depending on how much CPU cores you have. So what will happen, that if something is input from the input cycle, it will be sent to the control processor. The control processor, what it will do, that it will divide your instruction into 3 different instructions, and it will feed all these sub instructions to different CPUs. For example, a part of that instruction will be processed by CPU 1, a part of that instruction will be processed by CPU 2, and similarly to the CPU 3. Although RAM is a single RAM, there is no RAM 1, RAM 2, RAM 3, because RAM can be splitted as much as required. So a part of the RAM can be utilized by CPU 1, a part of the RAM can be utilized by CPU 2, and the remaining part of that RAM can be utilized by CPU 3. So what will happen by using parallel processing, that an instruction that requires 3 machine cycles can be performed in a single machine cycle. So the speed is enhanced 3 times. Okay, in this example. What are the future trends? We are hoping that in future we will be able to use different types of devices, different types of materials that can be much smaller than we have right now. For example, we have uh, 7 nanometers technology right now. We can go up to 100 nanometers, means get 1 upon 100 nanometers. Okay, so 100 nanometers in size, we can go much smaller. We can go to picometers, to the picometers standard. We can go by using carbon nanotubes, because carbon nanotubes are, first of all, they are very strong. They cannot be damaged by a spark of electricity or something, and they are so much lightweight. Okay, so that will obviously improve the lifetime of our CPUs. Okay, now quantum computing, we have already discussed what quantum computing is in the previous lecture. Quantum computing, as we know, that is a different type of mechanics that we have studied in the quantum, that we have studied in the Neil Bohr physics. Okay, so quantum mechanics or quantum physics is a different field which depends on different types of energy levels. The advantage of using these energy levels will have that we can now represent more than two states, because we have already known that transistor can represent two states, 0 and 1, on and off. So a single bit can have zeros or one state, but quantum bits or sorry, qubits can be represented by more than two states, because these are different types of energy levels. So different energy level can have different states. Okay, and it can more be two. It can be more than two. Okay, so with the arrival of quantum computing, we will have much faster computing standards that we have right now. Okay. Apart from quantum computing, there are different fields which are trying to bridge the gap between normal physics and the quantum computing, and these are by using different types of hardware. For example, in order to transfer data, we can use laser beams, because they are much faster as compared to normal wires. Okay, so optoelectronics is one of the field that is working on how we can use optical fiber type of medium in a computer, because optical fiber we can transfer data at much faster speed, but when it comes to motherboard it needs to be printed, but optical fiber cannot be printed that much easily in a motherboard. Okay, but researchers are working on it to make that thing much smaller, so it can be fabricated inside the CPU, inside the processor. Okay. Then we have silicon photonics. Silicon photonics is the hybrid thing which include both the optical fiber hardware type and the silicon that we are already using in CPUs. Okay. Then terrestrial computing is like increasing the size of transistor that it can implement into some like trillion transistors are implemented in a single processor. Then obviously the speed of the processor will be enhanced. But these all are slower. These all will be slower. Still will be slower as compared to quantum computing. Okay. Okay, 3D chips. What are 3D chips? 3D chips are the method in which we can fabricate these transistors in a layered fashion. For example, an apartment of buildings. If either you have a plot, okay, you either construct a home, a single story home in it, then how many people can live in it? For example, 5 or 10 people can live inside a single story home. But what if we make an apartment, a 3D building? So the number of people that can live in an apartment will drastically improve. Similar thing is with the scientists that are trying to make the chips that have different types of floors in it. So more transistor can be fit inside a single chip. So it will be termed as a 3D chip. Okay? Now this is the last slide of a lecture. Thank you very much. Allah Hafiz.